Greetings and welcome to Restaurant. In the previous video, we talked about how to count the number of iterations. Now, once we know that, let's try and use this concept to calculate the sum of a number of terms in a series without knowing the last term. We just know how many terms of the series we need to add, and that's it. That's how we'll get the sum. So again, starting with the first problem regarding sums that we did, that is finding the sum of first n natural number. Okay, and we'll do the same thing. We'll first of all define the first term of the entire series, right? And when we have that, then we'll say that every time we are going to add a term to the sum, all right? Also, we'll put s equal to 0. S is the sum. So we'll put the sum of the series equal to 0 because right now we have not added any term, right? Now, as we enter the loop, every iteration we'll be adding the term a to the original sum, right? The existing sum and a would be added inside the loop, right? And once that is done, an iteration is complete. So we'll add 1 to the count of the iterations, right? Now, remember, whenever we were putting count less than equal to 10 in the previous video, we got the value of count as 11, which meant that the iterations that have run, they have been run 11 times. But we want the iterations to run 10 times. So in that case, we'll just remove the equality from it. So that would ensure that the iteration runs only 10 times. All right. And that's it. That's how we'll calculate. After that, we obviously, just like in the previous videos, we have to increment the term a, or we have to update the term a inside the loop itself. And since we have to find the sum of the first n natural numbers, so in every term, a gets incremented by 1. So that has to be given here. All right. And that's it. Moreover, over here, this means that it would find the sum of the first 10 natural numbers or the first 10 numbers in the series. We want that to be general. So we'll say n equals to int input enter number. And over here, we'll just write n. Okay. And let's now print the sum. Now, when we run this program, we are going to get, let's say I am wanting to calculate the sum of the first 2 natural numbers. The answer should be 3. And this is the answer. So as you see over here, we did not really need to know the number of, the last term of our series. Rather, we just needed to know the number of iterations that we wanted to be run. We want to be run. So that's a very interesting way. We'll do a similar problem where again we calculate the sum of the first n odd natural numbers. And in the previous method that I mentioned, what you had to do is you had to update uh, the stopping criteria here. You had to make it based on the last term of the series. And that's not really obvious to us most of the time, that what would be the last term. So in that case, uh, it becomes a little hard. But here that won't be the issue. We just need to know the number of iterations and what should be the increment in each term. So since we have to calculate the sum of the first n odd natural numbers, so we just have to add 2 to every term. We have already specified a is equal to 1 here. So every time we'll be just adding 2 to it, right? And we'll be getting the sum here. So now if we run this, I'll just comment out the above code. And then I'll run the below code. So now if I type 2, so it should be 1 plus 3, and the answer over here is 4. So as you see, we are able to calculate the sum very easily, right? The only thing that needs to be done in this particular method is you have to specify the stopping criteria as the number of iterations. And you should know that how your term or how the terms in the sum have to be updated. For example, over here, it needs to be added by 2. So that is very important. Let's try. Now, this method is very gentle, and let's try to apply this to a more complicated series. So what we are going to do is we are going to calculate uh, the sum of n terms of a GP. So in a GP, those of you who don't know about a GP is basically a series where you have some first term, let's say A, and every previous term keeps getting multiplied by a common ratio R. So the next term would be A into R, the next term would be AR square, next would be R cube, and so on. So that's a GP, right? So now we have to calculate the sum of the first n terms of a GP. So we need three things now. First of all, we need the first term. So that could be a float or an integer. So I have just written float over here. After that, I need the common ratio, which could also be a float. And of course, the number of terms. Okay. And now we'll just use the same strategy. We'll first say that count is equal to 0. We'll define some sum equals to 0. And we'll say uh, while count is less than n, sum is equal to sum plus a. And now, as you see, we multiply r to each term every time, right? The previous term every time. So for updating this over here, we'll just write a is equal to a into r. So that means that r is multiplied to the previous value of a. So now the new value of a is a into r. And again, it would come into this iteration and it would just multiply r again. The new value becomes ar square and so on, right? And of course, we'll update the counter, right? And then we'll say that the sum is s, right? For a GP, we already know what is the sum of n terms of a GP. So let's try to find that using the formula that we already know. And let's see if our method actually worked out. So the sum of a GP is AR to the power n minus 1 whole upon R minus 1. So I have said, so now remember my A is the first term over here. So this A has actually gotten updated in the iterations here. So we need to make sure that this A, the first term, it is stored somewhere because every time this loop runs, the original A gets overwritten. So we don't want that. So for that, we just store the value of A in some other variable, say A1. All right. So this is the value of first term. And this gets stored in A1 always. So even when A is overwritten, A1 stores the value of the first term. And that is very important because over here we want to calculate the sum. So we have A1 multiplied by R to the power n minus 1 whole upon R minus 1. And that's it. So let's try running this. And when we do that, the first term, let's call it 10. And let's say the common ratio is um, 0.5. So we are dividing it by half every time. All right. And let's say we want to find the sum of the first two terms only. So it should be 10 plus 5, which is 15. And we have got 15 as sum, right? And let's increase the number of terms, for instance. So let's just find the sum of the first, let's say 100 terms. And we have got the sum to be 20. All right. So that shows that our method, it can be generalized. All right. One more thing. If you try doing this, finding the sum of the first n terms of a GP with a common ratio less than 1 using the method that I taught previously, you won't be able to do that. That's because in that method, we always assume that the subsequent terms of a series are increasing. And that is the basis of the stopping criteria that you mentioned over here. So in the previous method, when I was saying that your term A should be less than or equal to the last term, so that meant that from the first term to the last term, the terms of the series are increasing. Only then that stopping criteria would work. However, in this case, as we move from the first term to the last term, the terms are actually decreasing. And that causes a problem because the condition would become false in the first iteration itself and it would not calculate the sum. So that is why this method over here, where we use counter to count the number of iterations, that is more general compared to the method that we used previously. So the previous method that I taught, that would not be used now onwards. Now onwards, for calculating any kind of sum, it would always be recommended to use this kind of a method. That's it from my end. In the next video, we'll try to start the for loop. Thank you.